Hey guys, Christopher Mullen from VeFoil.com. I want to just give you a quick update of where we are in the grand scheme of things with the propulsion unit. Originally, as you know, most everyone started with the larger props in reduction gears, 140 millimeter, 130 millimeter. We kind of right off the hop jumped down to a smaller unit trying to streamline things more. This is 110 millimeters, and you got the reduction gear, and it's fairly long assembly, fairly heavy as well. These reduction gears are solid metal, and there's a lot of cost built into something this size, and that requires a reduction gear. So we are trying to scrap that for safety reasons. We don't want open props. We don't want all the other parts that go in here that create maintenance issues and the expense and issues with failing reduction gears. So we have moved on to smaller, more streamlined setups, direct drive. The motor bolts in here, threads right into the tube, and we've got the 80 millimeter setup with a nozzle here. We've oversized the nozzle. It looks pretty extreme. We've got water vanes in here. The plan is test it, chop off, shorten it as we go. That will increase the nozzle hole. Right now we've got the nozzle hole smaller than it should be. The plan is as we shorten the unit, the nozzle opens up, we'll increase the pitch. Eventually there'll be a point where the pitch starts to go fade away, and that'll tell us where the sweet spot is, and then we can adjust the nozzle to work with that fairly well. Now the next one we're working on here is a much more streamlined little teardrop system. Very affordable, very clean, same type of thing. We've got the water vanes in there, and the plan is to test it, chop the nozzle shorter, and see where the sweet spot is for thrust going forward, and go from there. Last but not least, we're working on one other, just a plain impeller jet drive. This is just a mock-up. We've redesigned an entire new model. This is just to give you an idea, but typical, you got your inlet, you've got your nozzle, you got your water vanes, and your impeller inside. And so we're going to be testing that as well, but not this model. We've redesigned a new one. So going forward here, looking at the different props, we have got a typical ducted quart nozzle prop, we've got a typical impeller, and then we've got this hybrid. This is a very interesting hybrid prop. You can see a much higher profile than a quart nozzle prop, a little bit lower profile than the impeller, and it's actually, we're working with two guys out of Germany. One guy is a inventor and good at CAD. Another guy is a propeller specialist, and so we've created the prop that will fit inside of this nozzle here, and it's designed to have the amount of thrust that we need at a certain RPM and give us the speed that we're looking for. So this one has been perfectly designed to go with our system. So we'll be testing this, cleaning it up, smoothing out, and testing with, we'll be testing with all of them, but obviously this is the one we're really focusing on, because this one is actually designed for the torque of the motor, for everything else. As you get into bigger impellers, they require a lot more torque, and you might not get the RPMs you need. So this is a hybrid, taking everything into account: RPM, thrust, speed, the thrust at a certain speed, and obviously the torque that the motor can provide, which is why we've got these funky shaped blades, much different than a simple fan blade or a long impeller blade. And last but not least, we've got our ESC here, we've got our Beck, and we've got the Eagle Tree system with a LCD screen, so we'll be able to track with the RPMs. We've got an RPM sensor, we've got a GPS, so we'll be able to track with the different props the RPMs we're going and the speed that we're traveling, and we can start to calculate and adjust the props and setups for optimum speed and performance characteristics. Anyways, that's it. Take care.